to tell me why second messenger systems exist, you would tell me why do they exist?
To modify the signal to
Amplification, to amplify the response, absolutely. And also because some signals are what? Hydrophilic. Some signals, their chemistry, they can't go in a cell. So you need to have a receptor on the surface to have that. And then if I asked you to give me an example of a GPCR coupled second messenger system, could you walk me through, or you should practice a response of walking me through how the release of something, a signal out here that is coupled to a GPCR adenylyl cycloacidic AMP receptor, how that signal transduction pathway works. You should practice doing that. Okay?
Do we need to know how it stops?
Ultimately, you will know how it stops. Depends on how I mean, I would say, okay, how do you turn it off? It's just working backwards to get rid of everything. How it stops will probably be a conversation we'll have in a specific context depending upon what the signal is, what the exact chemistry of the signal is, what chemical it is. Okay? So yeah, we'll have that conversation, but in context, not generally. Let me just show you this other one. I like this one for two reasons. One, because you get potentially 2 second messengers from the same system. You with me on that? So here, this is the GPCR phospholipase C, either IP3 or DAG signal transduction pathway, and it depends on what scenario it is. In some cases, DAG is the second messenger, and in some cases it's IP3. Which one is it? The answer, honestly, depends. Depends on where we are. Case is an example of both. Okay. So let's look at this one. Same general idea, just a little bit differences here. I'll walk through this. Let's first start with no signal. We got no signal. We got the GPCR here inactive. We got our G protein intact, inactive. We got phospholipase C sitting over here in the cell membrane, embedded in the cell membrane. It's inactive. So everything around it are just phospholipids. Right? That's what this is, right? Phospholipids. That's a phospholipid bilayer. Okay, so that's what it looks like. Nothing happening. I mean, other stuff's happening, but nothing happening with regard to this. Then we get a signal. Here. Could be a hormone, could be a paracrine, could be an autocrine, could be a neurotransmitter. I think it could be a neurotransmitter. I don't know very specific examples. There must be. But it could be any of those. It depends on how it got there. As soon as it binds, that starts this signal transduction pathway, right? Everything's the same here. Receptor changes shape, activates the G protein. One of the subunits comes off, comes over here, and activates now this amplifier enzyme. It's just different. It's phospholipase C. What does phospholipase C do? Phospholipase C takes this. That's my phospholipid. This is the head. It contains phosphate. These two are the tails there. So that's my phospholipid. What does inositol, or what does phospholipase C do? Phospholipase C takes that and cleaves this bond right here. So what do we release? We release inositol triphosphate, IP3. And what's left over here? This is glycerol with 2 fatty acids, diacyl glycerol. So this is the other way of looking at it is that this up here is IP3, this down here is diacyl glycerol. You okay with that? One of them's hydrophilic and one of them's hydrophobic. This is hydrophilic. So it's going to go down into the cytoplasm. This is hydrophobic, right? You with me? So it has to stay where? Stays in the membrane. Staying in the membrane. Stays in the membrane. Right? You okay with that? Which one's the second messenger? Both. It depends. Sometimes, under certain scenarios, IP3 is a second messenger and diacylglycerol is just a byproduct, right? It's just waste product. Other cases, it's IP3 is a second messenger, it goes and does something, diacylglycerol is just a waste product. Did I just say the same thing?
Yeah.
Whatever. You know what I mean. I might have said the same thing twice, but you know what I mean. Sometimes one of them is the second messenger and the other is the waste, and vice versa. So let's say, for example, IP3 is the second messenger. So phospholipase C gets activated, we break this down, diacylglycerol is waste, nothing happens there, and it just stays there. And IP3 is the second messenger, and typically what IP3 will do, IP3 goes into smooth ER, or modified smooth ER, like sarcoplasmic reticulum or something like that, and causes calcium channels to open, and you get calcium coming out in here, and that's the cell response. So